right, this is another boring topic, but we have to cover it because I can't find any videos online that walk us through a full collection of how to clean up wires. And so many projects are using the electronics, even if they're mechanical, etc. So it's a critical point for improvement, and I see just a little bit of experience could go a very, very long way. Not even experience, just examples. And my first recommendation already has been thwarted because, as you can see, I'm about to show you. So Texas A&M University has an annual, maybe biannual project showcase, engineering project showcase. So you can walk through the auditorium and all the students have their senior design projects or similar scope, at least 1 year of effort put into an invention, a design, and build. My recommendation is make sure you get yourself out to one of those long before you've started your project and see a full array of use cases. How are other designers successfully making their wires clean and safe and organized and nice? What materials did they use? You're asking questions. How will I do this thing when you're reviewing, instead of paying attention to what's drawing your attention, which is, oh, it does this cool function, or we worked so hard on this algorithm. Pay attention to what ingredients did they use to make that pizza. So it seems that not only YouTube is lacking in content that can show you good and bad and an array of examples on cleaning up your wires, but also if you go and look for the galleries of photos that come from these events, like the engineering project showcase from Texas A&M, the photographers who are responsible for producing this content make sure to show you only things that are beautiful and having wires concealed. Whereas if you actually walk through the building and see how things are built, 9 out of 10 of them have circuits and wires exposed, and you can just learn so much. And the topics span every different discipline: pneumatics, and hydraulics and water and airflow and resonance and audio, signal processing, materials, health, biomed, and across all of those you'll see the full suite of possible solutions. Yeah, so we're not going to get very far here. I'll try to show you some examples in the lab. Okay, what am I going to cover? I will try to cover some ingredients that you can use to clean up any different kinds of wires. We'll get down to coming from circuits with small dupont pins out to enclosures, etc. All right, common types of ingredients from which those keywords you can explore and find very many custom options. And I'll try to put it in a context, break it down by goals. We have very simple solutions that are just get something improved from zero attention put on the wires to like full intention, where I'm putting my effort in the design and the actions to have a result really how I want. I'll try to note some strategies. These are all just the organization of this video is how do we just try to make it a little bit more methodical than here's a bunch of stuff. From the projects I've seen students build, just knowing that some of these ingredients exist could take them a long way, because you all are smart enough to do shopping and research, etc., to find the data that you need and the parts. Perhaps I can also use the Scuttle robot as an example, because instead of like a commercialized product, this is much more close to an invention that students would make. And so when we talk about short term, not everything has been decided, and many decisions will be changing forever because this is built for changing, and we don't know how the customer will, for example, use this camera. So we just drill a hole and we zip tie this cable here today, and tomorrow it might change. But that gets us, while we're testing or running, or taking photos and we don't want to see all the wires, instead we want to see the gadgetry, then it's out of the way. That's the one step better than nothing. First cleanup, it really helps to have a little bit of the things in mind at the start of your design, even if you don't know what you're building. This is paired silicone wire, and it also comes in an ordinary PVC style, and you can prototype loads of stuff with this. It's 18 gauge, so this is the most common style, fine stranded, the most common gauge that we use, 18 gauge, and the most common number of wires we need for power. You'll notice when you go up from the signal wires, you will suddenly go from carrying minimal currents to carrying some substantial current that's going to drive an actuator. Almost in every case, that actuator for powering it just needs 2 wires, and they need to be significant gauge, like 16, 18, and the bonded wire pairs are saving you the time of first measuring out how much, so you don't need to match up the lengths when you're building. It also gives you the color recognition, makes it simple for any new users or team members to be sure when there's many wires, which one is the power and the ground. And that bonding is, at the end of the day, it helps you with your cleanup. So we add, for example, here, let's zoom in. We've got a simple clear shrink wrap that's just been used as a keeper. It keeps this wire from splitting any further than we needed to split it to add it into the terminals. This stuff is called spiral wrap, or I'm sure it goes by several other names. Comes in different colors, black, white, and some transparent-ish variants. And the reason I like it better than this type of wrap or the mesh wraps is that it's much easier to feed onto a cable from any location. At a given location, you can say, well, maybe if you've already routed the wire, you can't measure the wire directly, and you can have a little excess here and a little excess here. Start putting it on. You'll notice that the length changes. So this diameter is larger than this diameter, so I'm getting shorter. I don't know by how much, so I just start with a piece larger than I need, and I can get it wrapped. The nice thing about this, it has, it will not make your wire more rigid by much, like something like this, and this is going to add rigidity to your cable, wires, etc. And so if you really want to maintain flexibility, that's nice. Another tip for this is just to snip a small piece, and you can do something like just add it temporarily to a spot. Okay, I'm getting this stuff organized so I can see where my wires started or finished, clearing up space, essentially. Also, this spiral wrap is more forgiving with a broad range of diameter, whereas this, you need to know what's the diameter that you're working with beforehand. And secondly, if your situation turns into a Y, if my wires branch off, I can choose, do I want to follow all of them and crunch it down? Or do I want to just follow one pair? And I can do that. I can make my decision while I'm doing the action of wrapping. Sometimes you'll change your mind, and this is a method to see where you want to go with your wiring cleanup while you're doing it. And it's so cheap that like you can slice a different length, and one spool will give you more than enough for a project. These things are called ferrules. I covered these in another video. I'll link it somewhere. And you can see when you insert that into a terminal, it gives you a reliable clamping. It gives you a clean look on your wires, and these are designated specifically for a certain gauge of wire. They come in packs of like 1,000 with several different common gauges. And then, you know, that's going to go into here, and it's better, in my opinion, than just tinning the wires. You can combine this with tinning too if you need a really surefire, high amperage connection. Then you can tin your wires and still slip one of these over. Usually you'll need to increase to the next gauge up. Okay, zip ties are a legitimate solution, and you can plan ahead for them and get a much better result. So now this end of the tie is concealed inside of this enclosure. I can cap it off, and it can just help me. In this case, all I'm doing is keeping this clear from the desk, because the radius of this heavy wire will bulge out. So I'm closing that up, preventing snags, etc. So zip ties are appropriate for many situations. Let's see, one thing is, if you shop from an industrial vendor, you can get data sheets and specifications like diameter, force, the maximum tension they can withstand. This one's UL listed, and you can get the material spec, and you can be sure if it's ultraviolet rated, etc. So these can be very as professional as any fastener. If you're going to zip up a whole project, then I would recommend maybe one of these guns that gives you a couple of good things. So you cinch that down by hand, however you can get to it, and then this front end clamps onto, I'll get some focus. You slide that in there, okay, and then we're gonna pull this, and it's gonna cinch it down until it reaches a certain tension, and it's gonna snip it. Oh, it also fires off the end of that across the room, so wear eye protection or something. You can adjust the tension. The ways you can fail with this gun is you can over tension whatever you're binding, and you can actually damage something if you've over tensioned it and your zip tie is strong. You can break the zip tie if you have this tension dialed up high, and the tension is variable. So in this case, I can turn this knob, and it will increase the amount of force that this will pull before. Now the force is controlled with your hand pull. That means you can't over tighten if you're familiar with the feel, but you won't get the clipping until it has reached a certain, this little jaw here will slice at the tension indicated here. This does not have a specific, like Newton meters. It doesn't have a certain unit. This is, just take some practice to decide, okay, where is it going to be? However, what I have found is it's easy to get the tension wrong if you keep changing your zip ties, big, small, etc. But with one particular size, this will be very, very consistent, and it cuts it very flush. So that's another ugly thing that happens with zip ties. When we can't get a tool in there, or we don't have a very nice flush cutter, we can do that. When it comes to achieving that flushness, the proper tool helps. Once again, these are actual flush cutters, Eigen brand. Really like them because they're strong, and you have that true flush surface here where the jaw is closing down. I don't know what's going on with the focus here. These are dikes. They are not flush cutters, and you can see that there is a indentation here, so you will never get something fully flush. There will always be this amount of distance, at least, between your nearest face and your cut. So if you want to get into removing zip ties or cutting them flush, then and you have delicate wire situations, this is very helpful. Okay, and it's an easy snip to relieve it. That you can see the mark that the zip tie left, and that's giving you a little bit of information about how tight it was. So practice helps a lot. A little bit of practice. Spend money on a few extra zip ties, and then practice before we start. Zip ties are also called cable ties, and then we have the mounting style. They look like this. You can pass a screw through there, and you can fasten your wire to the face of wherever you can put a fastener. Here's an example of just getting wires out of the way using a mounting zip tie. And by this time, I have enough supplies. I choose the color intentionally. If you don't have any other criteria for choosing a color, just choose the same that blends in, because wiring situations are always busy enough without contrast involved. Okay, my workspace here is always changing. I'm always switching tools for different projects, and so more temporary than zip ties and more reusable is this cable cuff is the brand. Unfortunately, I think they're patented and there may be only a couple of competitors, but this has been very useful. I'll just grab a loop and cinch that down depending on the length that I want to get out of the way. And then we have this little bulk. If you don't want to have the bulk, then just do one more bend so that falls in line with your cable itself. Just a simple tip that I use. I really don't like that we're talking brands here. I really just want to show you the function. I painted that one, that's silly. But cable cuff appears to be the larger option. These were at Home Depot, pretty affordable, $1.50 each or something. And these ones are around $1 each. So of course you can get different sizes, and this one they call the cable click. So these have been pretty helpful, and sometimes they just get in the way. One more feature that is often overlooked is there's this spot where you can click it on. So like if I have a small cable and I'm wanting to wrap it up and unwrap it for use, oh gosh, see, that's trouble. I have a feeling it's a little bit hard to bend this out of the way and get it mounted on, but the idea is you can keep it near or attached so you don't lose it when you've uncoiled the wire and then coil it back up. Basically, I consider this to be a replacement for times when you see Velcro wrapped up around wires. Here's a workstation that we can show zip ties integrated with, in this case it's a 3D print, but you'll actually find with many electronics components, they have passageways to add zip ties as needed. So in this case, this is specifically designed to add a second securing point. This is securing point 1, this is securing point 2. It points my wire, my cable, down to where I'm going to plug it in. So any given tug from these directions won't create very much tension. I've secured it using 2 zip ties. And then you'll notice that the direction that you've placed that housing, the click housing, does matter. And so insert those thoughtfully. Your clearance begins to matter in many of these occasions where, okay, I need to have that clearance on the left hand and I want it flush up against the right hand equipment. So I'm gonna do that. And then you'll notice many of these terminals also have a feature for including zip ties if you need to. So you could pass a zip tie through here or here or here, and it gives you several options for snugging up a wire temporarily. And you need to just consider your own use case on what you're going to do for that, but just knowing that this is here ahead of time is going to help. When you secure a wire, a cable, to a place that's going to move, you're going to have to decide where you want to pin it down. And the default answer that should help you is, all right, so the question is, how do I mount it such that I don't have an excessive tension when I swing this assembly across its full range of motion? And you might not know that, or you might not have clearance while you're building to do the sweep and pick out the longest distance of wire you're going to include in that final loop. and you might not, I forget the other constraint, but instead of doing math, you can, in this case, I placed a magnet on here, but this is the answer of where can I place my, my securing point so that there's not a change in tension here. That answer is in the axis, anywhere along this path. If you mounted it here at this top or there at the bottom, you will not have an elongation or a tugging on this cable. So that's a much easier way to think about it. Okay, so I have two joints here. Now, the first joint is actually on the wall, and once again, the closer I can get this pin to that exact hinge location, then the less movement I have right here in this whole assembly. And then, yeah, so 2 points is the minimum to have a constant distance here will be held, secured on the wire, and a constant distance from here to any other location. Here is another example of the same thing. We have this hinge, and it's going to be moving many, many times. And I want to pin this wire down somewhere so that it's not moving around. It can't get snagged on a piece of wood or debris. And I've zip tied it straight onto that location there. And then also the bottom side doesn't have any, we're not pulling any length from down here such that this has to come up and down when we're making this big motion. Well, there's no feature here. It actually was a hole that I want to zip tie to. How do I do that? Well, pass something through the hole, come out the other side, and I don't know, in this case, I zip tied a washer. How much can your wire be bent and tugged and snagged, or even how much abrasion can it withstand? You can notice that every cable in your life has a design for some use condition. And this one comes from a vacuum, so it's more flexible than most of my extension cords by a large margin. That's wonderful. And it has inside of it a cord. This is cotton or polyester, or maybe even two materials for a cord that allows me to, yes, I could literally tug on this thing and this cord itself can withstand tension. And so consider that if you have the chance to select a cable for your project, there's a big difference. So when you're deciding how do I secure it and clean it up, you're deciding I'm doing this for the goals of tolerating abrasion or tugging or organization, and all of these come into play. So the thickness of your insulation gives you a factor that says, okay, this can tolerate a sharp radius, whereas a solid core wire can't do that without kinking the wire. The thickness of these vary quite a bit. The roundness should be considered, whether I'm working with a round cable or not. This tells you how many different directions can I bend it. The bending direction becomes more crucial when you're wanting to tidy up ribbon cables, where you can bend them to take out slack. And so if I have this wire longer than I want it, then I can put an S bend in there and zip tie that. It lies flat, it's neat. Getting cables oriented where you want to go. This is one thing to consider is you can purchase adapters for most USB and other common connectors in many different configurations. It's sort of an added cost that's not desirable, but in some cases it may call for it. So in this case, if we had a larger component in here and it was very tight, and yeah, we could bend the wire here, but if we bend the wire all the time and then there's vibration and shock, it's going to always be putting that pressure right there on my joint. If this connector breaks off of my board, the board is darn near useless. It's a critical connector, and So to guarantee we're not putting tension there, we can put this 90-degree angle and then secure that somewhere right at the top. Probably more people should know about these. They're called mounting bases. Again, probably with several other keywords. This one, I don't know if it's offered by 3M or if they just include the 3M adhesive, but if you have 3M adhesive, you're looking at something that's good quality. And oh, they go nicely with all different cable ties. This one in particular, it also has holes, so you could screw down this to a flat spot, and then you still have access to pass a cable tie in this direction. So the foam is really not reliable for holding any more than the weight of a wire. If you're tugging or if you have motion in the machine, then you really need to fasten it down more securely, but this gives you a way to connect your cables on a flat surface like we did here in a 3D printer. So now I can run this cable across and not have it snagged on any other equipment, and put an LED inside of my printer so we can see our prints better. You have a rough textured surface like this wall, or if the coating of the surface could easily come off, then you do not want to use the mounting bases there. This is where I'll select a cable tie instead, and the type which has the hole at the end. Many student projects are using this aluminum extrusion. This is the 20mm size, and this is the 30mm size. 20 is so extremely popular now. You can get it many different variations on Amazon, and so that's great for doing mechanical assemblies that are paired with electronics. If you go out and go shopping online from the same vendors that sell these extrusions, they will often have attachments or brackets, etc., that you could use to secure wires. So that's one thing. The other thing is that you can tuck wires into these grooves at any of the different faces. And then there's a component available that comes in maybe like 4 meters or so to a spool. Very affordable. And then you can snip a length of this. It has a profile that grips the two faces, and then you can just snap that in gently. It's not even a snap, it's just a shove, and it sits very elegant, and it's not flush. It's a little bit more protruding than flush. Gives you space to put quite a few wires there. Should note that this stuff is very easy to cut, even just with a pair of scissors. You get it fairly flat on your cut, and my recommendation, the only thing I gained from experience that would make me more prepared is if you want it to be very precise and achieve this length, then cut it a little too long and then push it down in there and then rub it back and forth once so that there is some friction here, and so that friction can cause it to stay condensed or expanded, and you want to kind of work that out so that it's neither compressed or stretched when you make your final cut to make that flush. And then you will not have any gaps there where it meets the edges. It looks to be this item does not have a very standard name, but you could look up slot cover, extrusion slot cover, flat seal. Yeah, maybe seal is a good keyword, because when you look up slot cover, you're going to get many other things as well. So just do a little shopping and you'll find it. I should mention something about that it pertains to all my videos, and that is I don't like to throw links at you, because I want this content to last for 10 years. What my goal is to add the value of knowledge about how to do things and what components to use from the mechanical, electrical user standpoint, not to say, oh, this kind of brand is available now on sale. If you're watching this video in 2030, then I've achieved my goal, because if I send a link, if I include a certain brand, then that business could go out of business, or you could be in another region of the world where that brand isn't available. And so all of our designs and the publications that I make in written content, etc., I'm aiming to not just deliver a solution today, but the knowledge base so that you can help yourself in any part of the world, any language. People have mentioned that I speak slowly sometimes. That's because it translates better, and the automatic captions work better, and this engineering and design knowledge base should not be localized to one year, one region, and that's the same method, the same outlook that we place with the whole Scuttle Robotics design. Some cases we're purchasing things that cost more, and it's going to cost the students more to invest in this equipment that we've recommended, but that equipment has been on the market and refined and characterized for 20, 30, 40 years. And so that's our guarantee that it's still going to be around 10 years from now. And if you are a student and you're learning right now, everybody's a student, maybe. I'm still a learner continually. And if your time is precious, the time you're learning is what you're training to add value in your career. And if you learn things that expire next year, steer away from that. I would recommend not to invest your time in studying anything that's going to be gone next year. And how do you know that? Because if it wasn't here 2 years ago, don't study it today. Let it settle out. That will create more refined technology, that will create more abundant instructions, and allow, when content is created that's instructional or that's shopping related, it will become more refined so that many people will waste their money buying the wrong option. They'll update the diagrams, the images, the designs, and the usability, and let time operate on your side, because in so many cases, if you're embedded in technology, then time is something that you're always fighting against, since things are moving so fast these days. Okay, this brings us to our next topic that will involve shopping. This is called cable ducting, or slotted cable ducting, cable tray. It has many names, and this is something that it's an industrial style part. It started in facilities and now it's available all the way for the consumer, but the standards are way more deviating and all over the place compared with something like DIN rail. So this rail, there is a very most popular size. It has vastly more volume and brands, and when you get any DIN rail, it's going to be this size or like two other alternatives that are much harder to accidentally find. Anyway, so this is so easy to work with. It's easy to choose. You choose the length, and then you can choose later if you need to extend it. It's hard to notice a seam, and you can also cut the top separately than you have cut the base. And so that base, I can make that long and then make this segmented, and then however many fasteners I need to mount it to a wall, then I can choose those, space those out. It takes fewer fasteners if you have one long sturdy piece. Also, it's best to cut, if you are cutting the same length, the cap and the track, it's best to cut them with this top secured to that. That way you get the perfect flush spot, and you can even choose, all right, I'm not going to interrupt one of these tabs. That's great, very easy to slide even a long length. This is PVC material, and it makes it so that you can continuously change your mind. And so I moved this wire, now I can just pull that out of there and bring it over here and set it through that slit. Very, very good for a place when I know where my wires will go, but I don't know how many wires and where they will exit. All right, so that's a solution. These smaller ones, but this is much more consumer grade. There's an excessive abundance of styles, brands, and types, and therefore it's really hard to find a size. At least I haven't. Maybe someone else can give me a tip on this. The size of cable tray that is near to this size, I don't know, say 2 centimeters by 3 centimeters, that is, I can be surefire to find it in another brand. If I got this brand today, surefire to find the same cap, like the mating of these two components. Well, what if I build something this year and I want to extend it later? Usually they come in kits, so consumer-wise, on Amazon, etc., they're coming in kits that have these little joints that'll cover up a gap. If you've put 2 segments together, that's cool. I drilled this hole to send the wire out the corner of the side, and they often come with this adhesive. So step 1, I'm going to place this on the wall or the desk with the adhesive backing. Super easy to mount, also super easy to cut in the same way. And step 2 is I changed my mind, I want to move it, so I just ripped that off. The adhesive is no good anymore, but the inside of it does have, usually for most brands, it'll have holes. Yeah, holes with a specific spacing. Now you can use those holes as indicators sometimes. If you're doing a lot of this, you don't want to be measuring every single piece. Now you can use that as a count for, okay, that's probably 15 centimeters or something, and you can just count those segments. Trouble is, consumer grade, this comes in packs that are not long boxes. They don't want to ship very long pieces, so they're shipping many small pieces, and if you want to run a long distance, now you have this disaster of many pieces stuck to the wall instead of just one big one. Don't forget that Velcro is an option for hanging or looping wire bundles, and it's nice, but I don't use it very often. I would recommend, however, one tip: choose the style of Velcro which has Velcro on both sides. That way you don't need to measure out the length as I do with these spools. It's so easy to have this wind up in a drawer, and it shears off the paper, it gets stuck to itself, or you lose track of how long you cut the first piece and you want to match up the second piece. This saves you that step. So double-sided, no adhesive. I don't like using glues with fuzzy things. It's just usually not reliable. So then we do things like grommets, and this can be done with hand tools and a simple punch. I'll try to include grommets in my hole making video in the future. When you're setting up systems with appliances and you're working with tight clearances, these types of adapters, plugs, can be a nuisance, and just to get an extra inch, sometimes that's a make or break for building an assembly. And so this type of connector, these types of plugs are quite useful for getting you that clearance, but consider this: if it contains a ground, then you will only have one direction. With this plug, I could potentially choose this way or this way. Maybe. It looks like it even has the fanned out terminal, so I can't change that. But if you choose this low profile plug, you only get one direction, and that direction will be where dictated by the ground pin. Okay. Ideally, these usually go down, even if they're going to travel up. A downward loop means any splashed water will drip down and not into the terminal. Don't look at all this cable mess. It's a work in progress. But this cable clip is an example of, just consider that you can design any of your own clips that will secure a wire to something rigid. And this round one is nice because this is a parametric design. So I've posted this on GrabCAD, and you can change, for example, if you make it twice as tall, that's just changing one variable, and now the model is updated and you can print your own in a custom shape. Make it twice as tall, it will have twice of the clipping, rigidity, and snappiness. You can change another variable. It will adjust the shape of this hoop, and it will update the whole model, not break it, and you're ready to go. That is in SolidWorks. I've also posted the other files, but SolidWorks is the native. GrabCAD, this thing is called Cable Clip Parametric, and I think I've included a little bit of information about how you might adjust this model on your own. Super easy without really knowing SolidWorks. If you have access to it, now you have access to adjust this model and just use my instructions. Another thing to consider for wire cleanup is a situation like this. So you have an adapter and there's a cable, two cables you need to clean up. Well, if you have control of the design, then you can do this a little more strategically than just random leaving extra length. This has a higher voltage. Well, if it was DC to DC, this is higher voltage, and it takes a thinner cable because there's less current. So on your high voltage side, the current is lower, and you have a more affordable cable. You can afford to give it extra length if that's one of your constraints. In the case of AC, in this case, we're going from AC 120 volts to DC, and so if I was going to shorten this up and clip wires, then I get to choose, all right, this one is a more durable cable, this one is creating resistive losses. So I will extend this part and snip this one short so I have the least resistive loss and the least part of my assembly where the more fragile cable can get snagged up or cut. There are many appliances nowadays that understand that the users have too many cables everywhere, and there are compartments that if you don't take any time, you won't notice any of these appliances. I'm laughing because it's a ridiculous amount of cord, but they've accommodated beforehand a space for the user to shorten their wires without cutting and clipping, and then cover that back up. And so take a look at your appliances. I'll give you another example. This is the Amazon Astro robot, and it's a piece of junk, but they have a really good quality charging station, and they've created those places here. In my case, I'm aware that these nested cable zones exist, and they've even considered putting outlets. So if you're a designer, think about doing that too. It's not an outlet, just places to allow things to be more flush with a very simple feature. In my case, I know that this is here, but the day that I buy the appliance, I'm not thinking about tucking away cables and making things neat. I'm deciding where I'll even put the charging station. And then months later, when I've arranged the space, then I'm going to tidy things up, and I may forget that this is here. So many home appliances have that sort of feature. Sometimes the right thing to do is just go ahead and shorten a cable for one of your appliances. And you shouldn't be afraid to do this. Just be thoughtful. What my worries is that I need this connection whenever I repair it, put it back together. I need it to have equal current carrying capacity, equal robustness or toughness, and basically not diminish any of the features. So this is a very quick solution that doesn't include soldering, except maybe tinning the tips. It's called a lever wire connector. There are, once again, just in the last couple of years, it exploded in the number of brands and options, but Wago is one of the first and very reliable options. You lift up this lever and you're gonna insert your wire there. It is fairly deep. It's deeper than you expect, almost down to the middle. And then there's a spring that compresses that wire down as soon as you snap it. Careful, these are strong and they will snap and pinch your finger. And so here we go. We get These generally, most options are appropriate for the size of wires that come with appliances. Almost all appliances, from your computer to your vacuum, are going to be around 12 amps or less. Really, I just consider that 10 amps. They're usually 12, 14, or 16 gauge, and this will accommodate any of those. It's especially nice if you include a ferrule, okay? But like I said, so this housing is going to consume all the way down. Look, I've even left a little bit at the tip, so it's longer, deeper than you expect. And where you can go wrong is if you think you've inserted it here, somehow it bottoms out, and then you pinch it, this can fall out. And so this discussion was all about, okay, if I just went to quickly shorten a wire and then take control, of course we don't have waterproof but we have these nice little brackets come along with the kits that give you a place to mount them, all modular. And so the modularity is beautiful. You can rearrange that stuff and pin them down where you need to. Use a terminal like this, then definitely do the tug test. Definitely, like, if it's your first time using any kind of connector, try it out and abuse it a little bit before you put it into use, just to make sure you've understood that you've built it correctly and that it's functioning correctly. The other very common types of these have, instead of, they're half as long, and they only can include terminals in one direction, and then the pins lay down, and it's just a one common rail of conductor. Online now, I mean, this is pretty recent that you can have so many options. These that are affordable, different numbers of terminals, and different configurations. So we're branching off from one to, oh, I ought to get something like that. I don't have a solution for that. Yeah. Oh, what I was going to say is these originated, at least this style, originated as a replacement for those wire nuts that electricians use when they're wiring up solid, non-stranded wire. So you should consider that this use case, the design will not be, like, for example, it is best suited for stranded wire and solid wire, not stranded. And so if you're going to use it, then you need to accommodate that. This is why I use the ferrule, or you're doing a very nice job of tinning the tip of your wire. If you don't know how to do that, then please look at a lesson on how to tin the tips. Okay, DIN rail is getting more popular. I have to make this interjection before I forget. I understand that this system is still kind of intimidating for a lot of people. They've never seen how it all goes together, and it looks very industrial. Well, it does come from industry, but it's not so scary. And there's tons of resources on how to do it, as well as once you have your circuits on DIN rail, cleaning up your wires, rearranging your terminals, expanding something that only had 3 outputs to 4 becomes such a breeze. It makes everything so much easier, and anything not carrying real power and current, you can work with, small gadgets like this. If you're going up to 100 watts or over, 3 amps, and you have several actuators, you will not regret going to DIN rail. And then if you run a lab, or if you're procuring for a group, this investment is so worth it. It's so simple. All this contraption just for making one type of cut. It's 2 steel jaws that will last forever if you're just cutting mild steel DIN rail. It cuts precisely how you want to. It has a measuring. So, like, this is just one example of how the world is very well equipped to help you build things with DIN rail, and it's the cleanest way to get wires put together for a large amount of terminals in a small space. Tip related to this is just that you should pay attention. This is more abundant on consumer shopping than this. This is steel, this is aluminum, this is stronger, this is weaker, and this has that curved profile that agrees more often with when industry decides to build things with din rail. They're cutting steel and they're capable to do that. This one's easier to cut with a hacksaw. Both of them can be cut with a hacksaw, but the aluminum ones, sometimes they'll have a flange just to give them more rigidity, and then they won't. This one fits, but a common alternative is we'll have a small flange here where my thumbnail is, and then it won't fit in these dies. Okay, now I'm jumping all the way back down to small microcontrollers, etc. This is an invention. I can't remember what I called it. I'm gonna post it. I'll make a comment in the description about it, but it's just a pin cover. But it's more than this because it's a pin indexer. As you're designing your project, you're deciding which terminals you'll use for your connections, and there are many options. You'll wind up wanting to, I see students make a decision, but then they change it later so that they can fit another connector. These pins, 40 pins, each have different designations. Some of them are shared, and some of them you've got to have it to, for instance, connect I2C. That's my purple, gray, white. And so one tip is choose housings. Don't use individual housings. It is more likely to have bent pins if you get one little snag and tug it. So you have the combined strength of multiple connectors. When these pins get bent just a little bit, then you're also you're potentially deforming that little tiny connector inside of there, which makes your connection, without you knowing it, less robust. And so, okay, we need these 4, but the 5 pin positions are spread with a gap. This one's useless next to the rightmost. And so I'm still just purchasing this 5 pin housing and putting them all in so that now when I go to clean up the wires, this one cable has one connector and it goes in one position. Reduces my odds that I could misarrange the terminals. And then once I've done this, I've allocated these rectangular sections on my 40 pin connector. Then I can go and place this here as a reminder when I unplug this and I need to plug it back in. Now there's a spot. Without me having to count, I can lay this in the correct position every time. This is super easy to slice with a knife, and then you can make this 6 pins wide or 4 pins wide. It prints in just a few minutes on a 3D printer, and it hugs this, so if I flip it upside down, it doesn't fall off. This contraption in the classroom has saved more Raspberry Pis than anything else, because at any time you're connecting a sensor, you are only one misplug away from frying an entire, $50 board or something like that. So take a lot of care into planning. How am I going to relieve myself of the task of counting and selecting? The multi-pin housings are one option, and then if you have, they come in up to 2, we'll call these rows, 3 rows, 2 columns. They come in either 1 column or 2 columns. Both of them are good, and if you only purchase a kit full of 1 column, that's okay. It's easy to super glue these together once you've made your selections. So now I have something that's for sure. When you super glue it, I would not do it by hand because it's easy to misalign. So I would actually do it on a set of pins so that then it's choosing its own positioning when you bond it. And then it's okay to have empty pins there. This pin in the middle is not occupied, and that is totally okay. Later on, I can plug a wire in there if I want to and occupy that pin or borrow it. Doesn't hurt that I've already assigned a cable for this space. I could, okay, one dangling wire that goes off into another location is better than all these pins being individual by far. So if you are teaching in a classroom or instructing a group or ordering supplies, please consider purchasing these DuPont cables in ribbon styles instead of all these individual wires that just cause chaos. And then you can choose, I want 5 wires out of this bundle, and pull it apart. Those remain bonded so your organization is retained. The decision of which colors will be used for which pins, instead of making 6 decisions, you're just making 1. Okay, I'll start with gray and I'll go to green, etc. And while you're making that decision, you'll notice that there are other nearby components like a hobby servo that already has chosen. Okay, red is power and black is ground, then and white is signal, so I'll continue using white for PWM signals, etc. You can borrow decisions made by other smart designers. I think that's very useful. And then directionality of plugging these in. If you plug in your terminals, this is on any kind of Arduino, microcontroller, etc. If you plug in these terminals with the metal exposed on the outside, that gives you a place to probe and test. And so not only is this, this doesn't have any this tinned nickel plated or whatever steel, copper, does not have any insulation on it. There's no thin clear as there is in some components, and you can access it directly. And also you're testing both the terminal of the board and your connection at the same time, because the only way for you to make an electrical contact right now, in this position, is if A, the pin is contacting the board, and B, your probe is contacting the wire. And then, so if you have continuity between here and the other end of the wire, you check that first, and then you can just plug in and probe like that. Now we're doing the more tests you can do without unplugging and plugging, less disturbance of these pins, the better. Okay, I hope I didn't go way too far off topic, but the truth is that the wire cleanup also maps back to planning your projects from the very start. It also maps to the selection of your components, the ingredients to your contraption from the start, or as you're ordering your last components. And yeah, I understand that I stretched all the way from large AC devices down to small projects. Most of your projects don't have all of the above in them, but I wanted to cover this for the mechatronics world, students and project makers overall, because it seems quite uncommon that you get some instruction and tips that covers both powered devices, larger scale, and microcontrollers. And this is the essence. This is why we're putting microcontrollers into all of these projects, is because now traditional well-designed things can be controlled, or we can add sensors with these small wires. And so I really think they do belong together. Hopefully that's helpful. If you have questions, put them in the comments. And also, I love how much information I've been collecting from users who make comments. They're a lot of experts that are viewers, and thank you so much for sharing that information as well.